Dear young aspirants of second PUC, I welcome all of you for this session. In the previous session, we studied about atoms and Bohr's theory of hydrogen atom. Bohr's theory mainly based on the three important postulates. The first one is an atom consists of central positively charged nucleus and negatively charged electrons revolving around the nucleus in various permitted orbits. Okay? The necessary centripetal force is given by the electrostatic force. Okay? So from this, I will get this expression. And the second postulate is, according to Bohr quantum condition, the angular momentum is an integral multiple of h by 2 pi. Thereby I got the second revolutionary statement, I got this expression. If I divide 1 by 2, I will get the expression for the velocity of electrons revolving around the nucleus. From this is very clear that the electrons in the first orbit moves with highest speed. In the subsequent permitted orbits, the velocity is less. Okay? Right. So then if I substitute this in the second expression, I will get the expression for radius. We derived all these things. So from this, it is very clear that the radius of the permitted orbits is directly proportional to square of the principal quantum number. Okay? So using the expression for radius, we derived the expression for total energy of the electron in the permitted orbits. That is the sum of kinetic energy and potential energy. It comes out to be this. So if I substitute for the radius in this expression, I will get this expression. Minus mz square e power 4, 8 epsilon square n square h square. Here, our main observation is the energy of the electrons in the permitted orbits is negative. Okay? So they are not free. The electrons in atoms are not free. They are in bound state. To make them free, to remove them from atoms, we have to supply energy. Work has to be done. It is a very, very important merit of Bohr's theory. Okay? It gave expression for velocity, expression for radius. It explains why electrons are not free, why electrons cannot be easily removed, why energy is to be supplied to remove electrons. So that is the merit of Bohr's theory. Okay? So from the negative, that is the significance of negative sign. Then according to Bohr frequency condition, the electrons revolving in the same orbit didn't absorb or radiate energy. The total energy of the electron remain constant as long as it stay in the same orbit. When it jumps from high energy orbits to low energy orbit, energy is emitted. When it jumps from low energy orbit to high energy orbit, energy is absorbed. That is Bohr frequency condition. From this, if I substitute h nu and nu is equal to c by lambda, so I will get the expression for wavelength. We derived all these things. So this is the expression. There is a reciprocal of wavelength is called wave number. The expression for wave number is rz square 1 by n1 square minus 1 by n2 square. This constant, all these things togetherly, we will denote it as r. That constant is called Rydberg constant. Okay? We derived all these things. Now, if I calculate the energy value, if I substitute for mass of the electron, charge of the electron, permittivity of the free space, then for the first orbit n equals 1, h Planck's constant value. So all those values will be in your logbook. So note down and substitute and simplify those things. I will get it in joules. If I convert it into electron volt, that energy value comes out to be in the nth permitted orbit, it is minus 13.6 electron volt divided by n square. For the first orbit, n equals 1. The one value is this. Second orbit, 2 square divided by 4, I will get minus 3.4. For the third orbit, 3 square 9, I will get minus 1.4, 1.5. Then similarly, this value goes on, negative value, magnitude of the negative value goes on, decreases. As a result, the energy of the electrons in the higher orbits increases. Okay? So, in the lowest in the possible energy is called ground state energy. The lowest possible energy state of an electron in an atom is called ground state energy. That is in first state, n equals 1. Okay. So, when n equals infinity, 1 by infinity square, 1 by infinity becomes 0. Therefore, the energy of the electron is 0. Okay. So, now, see here, this is the nucleus, this is the first permitted orbit, this is the second permitted orbit, this is the third permitted orbit, this is the fourth permitted, fifth permitted, sixth permitted orbit. It is also called K shell, L shell, M shell, okay, like that. Okay. So now, the energy, the lowest energy state is this first orbit, that is called ground state. The higher energy states are called excited states. Okay? They are called excited states. If I supply energy for an electron which is in the ground state, it will get excited to higher energy states. Okay? So when an electron jumps from second, third, fourth, fifth, etc. orbits to the first orbit, I will get different radiations. When it jumps from second to first, I will get one radiation. It has certain wavelength. When it jumps from third to first, I will get another radiation. That is called, yes, I will get another line in the spectra. This set of spectral lines obtained when electron jumps from high energy states to first state, that set of spectral lines is called Lyman series. Okay? I will get you explained again. So about spectra. Okay. Similarly, when electron jumps from third, fourth, fifth, etc. states to second state, the set of spectral lines obtained is called Bohr series. Similarly, Paschal series, Brocket series and Fund series. So these are all the different spectral series which we have experimentally observed using hydrogen atom. So this Bohr's theory explains all these spectral lines. Okay? So these spectral lines, this Lyman series lies in UV region, this Bohr series lies in visible region, this Paschal, Brocket and Fund series lies in infrared region. Those radiations are infrared radiations. Okay, these are the high energy radiations, UV radiation. These are visible radiations. Okay, the first line of Bohr series, when it jumps from third to second, we will get first line. That line is called H alpha line. The second line is called H beta line. The third line is called H gamma line. Similarly, fourth one is called H delta line. So we have assigned the name for those spectral lines, so which lies in visible region. So this is how we will get different spectral series in hydrogen atom. So these are all the, what I explained so far are all the merits of Bohr's theory. Okay? So the empirical formula for Rydberg constant and the formula given by Bohr's theory so have excellent coordination. So the value obtained from this and experimentally, so they are in good agreement. So that is the merit of Bohr's theory. Bohr's theory gives expression for velocity, radius, energy and frequency, wavelength, wave number, and it explains the different spectral series of hydrogen atom. These are all the merits of Bohr's theory. Okay? So in future, if you think it, Bohr's theory cannot be applied for multi-electron systems. It can be applied only for hydrogen-like atoms. If there is only one electron outside the nucleus, Bohr's theory can be applied. If there are two electrons, it cannot be applied. If there are three electrons, it cannot be applied. It can be applied only for hydrogen-like atoms. Hydrogen-like atoms are H atom, then helium plus atom, lithium plus plus atom, beryllium plus 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 atoms. So if I remove one electron from helium atom, it will become hydrogen-like. Only one electron lies outside the nucleus. If I remove two electrons from the lithium, it becomes hydrogen-like. For such systems, we can apply Bohr's theory. Okay? For multi-electron systems, Bohr's theory cannot be applied. That is why it became a limitation of Bohr's theory. Then, so it failed to explain the relative intensity of spectral lines. Intensity means brightness. So if you take any spectral lines, so few lines appears bright, few lines appears dull. Why few lines are more probable? Why they appear more bright? Why few lines are dull? So that cannot be explained using Bohr's theory. Okay? Then it failed to explain fine structure. Fine structure means if I observe each spectral line with high resolution, each line consists of a number of closely spaced fine lines. Okay? That cannot be explained. That fine structure is due to ellipticity of orbits. Okay? That. So the concept of ellipticity of orbit cannot be explained using Bohr's theory. These are all the limitations of Bohr's theory. To overcome these limitations, we have to look for another very important good atomic model which overcomes these limitations. Okay? So the next atomic model is Bohr-Summerfeld atomic model. It introduces the concept of ellipticity of orbits that explains fine structure. To explain hyperfine structure, we introduces vector atomic model with the introduction of two more quantum numbers. Okay? Totally, finally, so what I conclude, so in this chapter is Bohr's theory introduces principal quantum number, Bohr-Summerfeld theory introduces azimuthal quantum number, then vector atomic model, the next model introduces two more quantum numbers. They are magnetic quantum numbers and spin quantum numbers. Okay? These four quantum numbers totally defines the state of electrons in atoms. But we didn't have Bohr-Summerfeld model and vector atomic model. So we have only these things in second PUC physics. Okay? So in the next session, all of you please observe. All of you calculate the velocity of electrons in the first orbit of hydrogen atom. You see, this is the expression. For hydrogen atom, Z equals 1, and for the first orbit, N equals 1. You know the value of E, epsilon naught and Planck's constant. Take those values from your logbook, substitute them and find out the velocity of electron in the first orbit. Similarly, find out the velocity of electron in the second orbit and third orbit. Okay? So all of you calculate and put as assignment. Next, you calculate the radii of the permitted orbits. Calculate the radii of the first orbit, calculate the radii of the second orbit, observe and see all those things. Okay? So, and calculate the energy of the electron in the various permitted orbits. Verify. So, through your notes, will you get 13 minus 13.6 eV by n square. So, there are the problems which appear in the examinations. So, I inform all of you to do these problems. Okay? Thank you.